co-author Amir Ibrahimi Fard and I, Rishabh Hada, will be presenting on behalf of our team. Before I start, I would like to mention that this work is a joint effort of an interdisciplinary team of researchers. It emphasizes the importance of more such collaborations to come up with holistic solutions. So what exactly is an echo chamber? As described by the Oxford Dictionary, it is an environment where a person only encounters information or opinions that reflect and reinforce their own. And why is this a problem? Because this can lead to rapid spread of misinformation and very high confirmation biases. It is also very bad for a healthy democracy because we want citizens to come in contact and engage with different viewpoints and on important political topics. In our work, we draw heavily on the deliberative democratic theory, which highlights the importance of political conversations between citizens. This includes online conversations. Thus far, past work has focused on studying online conversations with the metrics such as toxicity, rationality, and mutual respect. However, studying echo chambers is gaining importance. It is important to study whether and how different viewpoints come in contact with each other. In the news recommender systems domain, viewpoint diversity metrics has already been discussed. We take inspiration from the viewpoint diversity metrics conceptualized for the news recommender systems domain by Brian Hock et al. So in our work, we propose novel operationalization of two viewpoint diversity metrics specifically for the domain of online conversations. Our first metric is representation, which is a conversation level metric. It measures how the views expressed in a single conversation compares to the breadth of views expressed overall. Our second metric is fragmentation. It is a user level metric. It measures how different users within a conversation engage with different viewpoints. To the best of our knowledge, this is the first study to apply the two metrics to real-world data. We present in-depth analysis of the metric behavior and discuss what it means in the context of deliberative democratic theory. We show that echo chambers do exist for the topics that we studied, that is immigration in the US and the control topic of daylight savings time. I'll quickly discuss the data collection and classification pipeline. However, you can find more details about each of these steps in our paper. We followed a keyword-based sampling procedure for tweet collection. These tweets were then annotated for relevance, and our main annotation task was a viewpoint annotation. Tweets that belong to the diagnostic claim category highlight a problem that are associated with the topic. For example, daylight savings time interrupts sleep. Tweets that are associated with the counterclaim viewpoint counters the concerns identified in the diagnostic claim. For example, daylight savings time helps sleep. Using the annotated tweets, we built classifiers for relevance detection and viewpoint detection. Using the annotated tweets, we extracted the conversations around them using the academic research track of the Twitter API. These conversations were reconstructed as reply trees. Finally, we used the classifiers on each of these tweets and labeled every tweet in the conversations. So in this table, you can see the summary of the dataset that we finally used. For daylight savings time, we have about 1,700 conversations that lead to about 15,000 tweets. For immigration, we have 400 conversations. These conversations tend to be very long and lead to about 13,000 tweets. Using our classifiers, we label each and every tweet, and as you can see, the dominant class is the irrelevant class. The rest of the tweets are distributed amongst the other categories. Now let's discuss the viewpoint diversity metrics that we propose in the paper. The first metric is representation diversity. It compares the views expressed in a single conversation to the breadth of views expressed for the topic overall. In this example, you can see that in this topic, there are different viewpoints represented by different colors. In this conversation, each viewpoint is represented proportionally. That is, the divergence between the conversation and the topic is quite low, leading to low representation diversity. In this conversation, it is skewed towards one particular viewpoint. That is, the divergence between the conversation and the topic is quite high, leading to high representation diversity. So to summarize, at conversation level, this metric captures the degree to which conversations are restricted to certain views. We operationalize this by measuring the KL divergence between the probability distribution of the viewpoint categories in a single conversation to the viewpoint distribution of the topic. As you can see, for both our topics, most of the conversations have a very low representation diversity. That means that the discrepancy between the conversation and the topic is quite low. If the values were closer to 1, that would mean that the discrepancy between the conversation and the topic is quite high. Our next metric is fragmentation, which will be explained in detail by Amir.
Thank you. I continue this presentation by explaining the notion of fragmentation, how to compute this metric, and how are the results of this metric in our data sets. So basically, fragmentation is a user-level metric, which is the complement of overlap between users' viewpoint. So when there's a high overlap between the viewpoints, the fragmentation would be low, and when the overlap between the viewpoint is low, the fragmentation would be high. Here I explained how to compute fragmentation using an example. We have an imaginary scenario with 3 users. Alice makes a tweet 1 with viewpoint X, Bob replies to tweet 1 with viewpoint Y, and Carol replies to tweet 2 with viewpoint Z. The first step to compute fragmentation is to build viewpoint network. Viewpoint network is a multi-directed graph where every node corresponds to a user, and every edge shows who is exposed to whom and with what viewpoint. The next step is to transform a viewpoint network to a viewpoint matrix. In viewpoint matrix, every row corresponds to a viewpoint and every column corresponds to a user. We also call every column user vector. Then for every user, we compute the pairwise similarity between that user and the rest of the users. So for example, for user Alice, we compute the pairwise similarity between Alice and Bob and Alice and Carol. So please note when I say Alice, Bob, or Carol, I mean the user vectors belong to them. Then we take the average of the pairwise similarity, and then we subtract the result from 1. And then we get our fragmentation score for each user. So here are the distribution of fragmentation in both data sets. As we can see, the fragmentation in both data sets is highly skewed towards 0, which shows our users are exposed to similar viewpoints in both data sets. Now let's put both fragmentation and representation together. As my colleague Rishav explained, conversation about both immigration and DST follows the distribution of opinion in the full population. And as I explained before, the skewed distribution of fragmentation for both DST and immigration shows most of the users are exposed to similar viewpoints. But what can we gain by looking at these metrics together? So for DST, we can see the low value, for both DST and immigration, we can see the low value of representation show that all conversations they consist of majority of the viewpoints, and the low value of fragmentation in both data set in fragmentation shows that most of the users in our conversation are exposed to those viewpoints. We further investigate the presence of echo chamber in our dataset by looking at dyadic interaction and how oppositional claim and supporting counterclaim are interacting with each other. For the control topic of DST, when a user posts a tweet with viewpoint L3, it is highly likely that that post receives a reply with viewpoint L3. And similarly, when a user posts a tweet with viewpoint L4, it's highly likely that that post received a reply with viewpoint L4. However, in immigration, when a user posts a tweet with viewpoint L4, the chance of receiving a reply with L3, either L3 or L4, is quite equal. But when a user posts a tweet with viewpoint L3, which, as a reminder, L3 means anti-immigrant viewpoint, the chance of receiving L3 is 3 times more than L4. So here we have a clear evidence of echo chamber for anti-immigrant viewpoints in the immigration topic. So In conclusion, we looked at an important and timely topic of echo chamber. We measured viewpoint diversity using conversation level metric of representation and user level metric of fragmentation. We built and collected and annotated 2 data sets, one control topic and one more political. And by putting all together, we could measure if there is a echo chamber in our dataset or not. As next steps, we are expanding our dataset by looking at more fine-grained labels, and also we are going to look at the robustness of our results by exploring other design choices. Our codes and data are available in the GitHub URL, and you could always reach out to either me or Rishabh via this email. Thank you so much.